Yeah, good morning, students. Actually, we are in part 2 of a differential equations formulas. Yeah, in that, now we will see the logarithmic function formulas. Before going to logarithmic function formulas, just we touch the types of logarithms. So, logarithms can have any positive values as its base, but two logarithms bases are more useful than others. The first one is base e, the second one is base 10. The first one is base e, the second one is base 10. So in that first one, base e, yeah, which is known as natural logarithm. So natural logarithm is nothing but which has base e, log any function, any variable to the base e. So you're having base e. So already we have seen that is e is nothing but irrational number. So which has the value 2.718 approximately. So this log x to the base e, also denoted by ln of x, ln of x, usually pronounced ln of x, but by through the past history, ln might have mean for stands for log of Napier, log of Napier. Otherwise, just usually pronounced ln of x. So right, this is the natural logarithm. Natural logarithm means so absolutely which has base e, the base e. Whenever base as e in logarithms, that should be called as natural logarithm. So what about second one? The second one, the also most important. So base 10, which is known as common logarithm. Common logarithm. So that is, we can write like this: log x to the base 10. Log x to the base 10. Here, but we don't write in the form of ln. Just this is a common logarithm. It is always like this only, log x to the base 10 only. This is the second one, common logarithms. These are the most important in logarithms. Yeah, come to back the logarithmic functions. In the first one, d by dx of log x to the base e. So derivative of log x to the base e. Here base what he means, this is natural logarithm. Otherwise we can write d by dx of ln. So what is the formula of derivative of ln of x? That is 1 by x. 1 by x. 1 by x. So right. So second formula here, derivative of log x to the base 10. So base 10, otherwise any basis. You should write what? So 1 by x 1 by log 10. Otherwise you write any base, means if it is having any number, means 2 3. If it is 2 is there, you should write 2 here. If it is 3 there, you should write 3. So here having 10, so I'm writing this 10. Yes. And next one, trigonometric functions. Yeah, so the derivative of sin x, so cos x, the derivative of cos x minus sin x. So here you should observe this cos x, the start with letter C. So when I have in differentiation formulas, when functions having the starting letter C should keep what? Minus. Should keep minus only. The before answer you should write what? Minus. So here also the cos x having the first letter C, so you should write what? Minus. The minus sin x. The derivative of sin x is cos x, and the derivative of cos x is nothing but minus sin x. And what about tan x? Yeah, which is not started with C, so just 6 secant square x. Derivative of tan x equal to secant square x, and derivative of cot x, again you're starting with what? The C letters, so you should keep what? Minus. So minus cosecant square x, minus cosecant square x. So d by dx of tan x secant square x, and d by dx of cot x minus cosecant square x. Next, d by dx of secant x equal to secant x into tan x. So here again minus we got, so means again here's starting letter C, so minus cosec x into cot x, minus cosec x into cot x. So let you observe from here the sin x cos x is, we get the formula like this, opposite sin x cos x cos x sin x, in this manner. The second two formulas, tan x is the identity friend, that is secant, so secant square x. Here cot x, the identity friend is cosecant, that's why here minus cosecant square x. Here secant x and cosecant x both also like this form, secant x same as it is I'm writing, and just you should multiply the identity friend tan x. So already we have learned that is secant square x minus tan square x equal to 1, that is trigonometry identity 2. So in that secant x and tan x are both are friends, that's why I'm saying here tan x is the friend of secant x, that's why I'm writing secant x into tan x, the product of secant x into tan x. Here the cosecant x into cot x, so which has known that what? Cosec square x minus cot square x equal to 1, that is the identity 3, and both are friends, so that's why the product of I'm writing that is cosec x into cot x, the minus cosec into cosec x into cot x. Why get here minus means, should remember, that is here starting with what? C, just I'm saying you for remembering purpose. Yeah, now let me go for inverse trigonometric function. Inverse trigonometric functions. So derivative of sine inverse x. Derivative of sine inverse x is nothing but 1 by square root of 1 minus x square. So derivative of cos inverse x. So same, but again here what? So here again starting with what mass c. So that's why should keep what minus. Sin inverse x and cos inverse x both are same but small, quite different, that is minus in cos inverse x. So sin inverse x, derivative of sin inverse x, what? 1 by under root 1 minus x square. The derivative of cos inverse x minus 1 by under root 1 minus x square. Sin inverse x, here having plus, and cos inverse x minus. So what about tan inverse x? D by dx of tan inverse x. Just now we have seen that is sin inverse x and cos inverse x, we got the root. So but in that tan inverse x, we doesn't have any root. So 1 by 1 plus x square. Here doesn't have any root. Just you should write, okay, 1 by 1 plus x square. And all inverse trigonometric ratios. All inverse trigonometric ratios having in the numerator what? Only 1. So numerators what? Having only, that is 1. So what about cot inverse x? Cot inverse x means same, 1 by 1 plus x square. Again here starting with what? C letters. That's why you should keep what? Minus 1 by 1 plus x square. So this is the difference between tan inverse x and cot inverse x, just a sign difference. So plus and minus. Derivative of tan inverse x equal to 1 by 1 plus x square, and next derivative of cot inverse x is nothing but minus 1 by 1 plus x square. And the next one, derivative of secant inverse x. Derivative of secant inverse x is nothing but again in the numerator what? 1, and next mod x into x square minus 1. Similarly we can write same formula, but the small changes are there. That is what? Yes, that is minus again, which started from letter that is C. So derivative of secant inverse x equal to 1 by mod x into a under root x square minus 1. But the derivative of cosecant inverse x is nothing but just we simply write the before what? Minus. So minus 1 by mod x into under root of x square minus 1. This is the difference between secant inverse x and cosecant inverse x. Yeah, next we'll go for hyperbolic trigonometric functions. Hyperbolic. So hyperbolic means definitely will come this what? H means here hyperbolic. So you have seen that is what trigonometric function formulas. So those are similar to here hyperbolic trigonometric functions. So whatever there came, sine x equal to cos x, here also same, the sine hyperbolic x equal to cos hyperbolic x. And next one, cos hyperbolic x means sine hyperbolic x. But here an hyperbolic, we never get it here minus, because here no, again start with c, but here not get it minus. Just you should remember here we won't write minus before the sine hyperbolic x. So always which has positive. The first three functions, sine hyperbolic x and cos hyperbolic x and tan hyperbolic x. So sine hyperbolic x and cos hyperbolic x and tan hyperbolics are positive. The rest of trigonometric means rest of the hyperbolic trigonometric functions, whatever having those, are negative. So what are? they are cot x, sec x, and cosec x. Cot x, sec x, and cosec x. So they have minus. So here sine derivative of sine x is nothing but cos hyperbolic x, and next derivative of cos hyperbolic x is nothing but just positive sine hyperbolic x. And the next one, derivative of tan hyperbolic x is nothing but secant hyperbolic square x. Oh, we finish up to three trigonometric ratios. First one is sine, and second one is cos, and third one is tan. So these three having what? Plus sign. But rest of the trigonometric ratios what? So minus. So in that, derivative of cot hyperbolic x equal to minus cosecant hyperbolic square x. And next, the derivative of secant hyperbolic x is nothing but secant hyperbolic x into tan x. Again, don't forget about minus. Minus secant hyperbolic x tan x into tan hyperbolic x. In the same way, trigonometric functions also there's a case, same manner. Secant x equal to secant x into tan x. Here cosecant x equal to cosecant x into tan x. And hyperbolic also same formulas, but the little bit changes are there. So that is what only symbol means sign. Before sign is important. So in that trigonometric functions, just you should keep before C letters. But here first three plus and second three should minus. Keep what? Minus. So these are the what? Hyperbolic trigonometric functions. The next one, hyperbolic inverse trigonometric functions. Hyperbolic inverse trigonometric functions. Hyperbolic inverse trigonometric functions in that derivative of sine h inverse x. Sine h inverse x. So what is sine h inverse x means? 1 by square root of 1 plus x square. 1 upon square root of 1 plus x square. Here also same in the pattern of sine inverse x and cos inverse x. Yeah, inverse functions, whatever having in the numerator what? 1 only. Here also same thing. What numerator? Always numerator is should write what? 1 with what? 1 only. Here again same. Cos derivative of cos h inverse x is just the small changes is there, that is 1 by under root x square minus 1. 1 by under root x square minus 1. This is 1 plus x square. This is x square minus 1. So right. The next one, derivative of tan h inverse x. Derivative of tan h inverse x is nothing but 1 by, yeah, yes, tan and cot in whatever inverse or hyperbolic inverse, they don't have root. They don't have root and don't keep any root. Just you write 1 plus x square there, but here 1 minus x square. 1 by 1 minus x square. In tan inverse x, 1 by 1 plus x square, but here tan hyperbolic inverse x, 1 by 1 minus x square. And next one, similar, I'm writing here 1 by 1 minus x square, but before I'm keeping what? Minus. Minus 1 by 1 minus x square. So this is the difference between an inverse and hyperbolic inverse. And the next one, sec hyperbolic inverse x. So sec hyperbolic inverse x as well as numerator what? 1 only. 1 by mod x under root 1 minus x square. 1 minus x square only. So but here minus, you should write minus only. Again here also minus 1 upon mod x under root 1 plus x square. So this is the sec hyperbolic inverse x and cosec hyperbolic inverse x. So this is the part 2 of differential equation formulas. So next we will meet as soon as possible with part 3 of differential equation formulas. And thank you very much.